Good afternoon. Let us begin today's class.
Good afternoon.
Today we are going to discuss fuzzy inference system. Okay. So far we discussed a lot of theory behind this fuzzy logic theory. Today we will solve one problem. In the beginning, I will tell you what a fuzzy inference system is. After that, one problem I'll try to solve and I'll leave you early. We'll have quiz in the end, maybe around 5 o'clock. Okay. So coming to fuzzy inference systems, it has uh, five what I can say is 5 functional blocks. Okay, so fuzzy inference system has 5 functional blocks. The first block we call it as a rule base. A rule base. This contains normally if-then rules. Okay, the second one is a database. This defines the membership functions of fuzzy sets used in fuzzy rules. The third one is a decision-making unit. Third block is decision-making unit. This performs operation on the rules. Decision-making unit performs operation on the rules. The fourth unit is fuzzification interface unit. Fuzzification interface unit. This converts the crisp quantities into fuzzy quantities. The last block is defuzzification interface unit, which converts the fuzzy quantities into crisp quantities. Let me just tell you once again, a rule base that contains if-then rules, database. It defines the membership functions of fuzzy sets used in rule base. In decision-making unit performs operations on the rules. Fuzzification interface units converts the crisp quantities into fuzzy quantities. The last one, defuzzification unit, converts the fuzzy quantities into crisp quantities. The basic diagram of a fuzzy inference system is something like this. So this is the input and this is the output. So here we have fuzzification inference unit. So this is crisp value and this is fuzzy value. Okay, and here we have a knowledge base and in this we have database and we have rule base. Okay, database and rule base together we call it as knowledge base. So this is decision making unit. Decision making unit, and this is also fuzzy in nature. Finally, we have defuzzification interface unit. Output of this is crisp. Okay, this is crisp. This is the block diagram of fuzzy inference system. In general, any application you choose, that will have these many working units in that. Okay. So now let us go to methods of fuzzy inference system. So there are two types. One is, you might have heard this word, Mamdani FIS, Mamdani fuzzy inference unit. Second one is, we call it as Sugeno FIS, SUGENO, Sugeno FIS. Okay, this was introduced in the year 1975 whereas this came in 1985. So based on the type of modeling, these two methods are there, Mamdani and Sugeno FIS. I will not discuss how it works. These things I will not discuss. But one thing is, Mamdani FIS follows linguistic fuzzy modeling, and compared to Sugeno, the accuracy is slightly less. Whereas Sugeno FIS, that is, we consider it as like it provides better results, and precise fuzzy modeling is used in so Sugeno fuzzy model. And another important thing is, Mamdani is intuitive in nature. Okay, it is based on intuition, or it is based well suitable for human input. Whereas Sugeno is, if it is computationally, if this is considered to be computationally efficient. Okay, this is considered to be efficient. So if you are using MATLAB for fuzzy, this, if you are using MATLAB, there you can have the, you have the option of selecting Mamdani or Sugeno. Any one you can select. Okay, this is regarding the methods of FIS. Now what I will do is, I'll take one problem. Okay, a simple problem I'll take that. With that, I think whatever we have, the basic concepts will be clear. Okay, so I'll just write the here, design a controller, rather fuzzy logic controller. Okay, design a controller to determine, design a fuzzy logic controller to determine the wash time of a, determine the wash time of a domestic washing machine. Domestic washing machine. Assume the inputs are, assume the inputs are dirt and grease on clothes. Use three descriptors. Use three descriptors for input variables and five descriptors for output variable. Derive the set of rules for controller action. Derive the set of rules for controller action and defuzzification. The design should be supported by figures wherever possible. Okay. Determine wash time for 60% dirt and 70% grease using the model which you have designed. Okay, the problem is simple. Design a fuzzy logic controller to determine the wash time. Okay, so this is the output now. Wash time is the output of a domestic washing machine. Assume the inputs are dirt and grease. Use three descriptors for input variables and five descriptors for output variable. Derive the set of rules for controller action and defuzzification. Determine wash time for 60% dirt and 70% grease using the model which you have designed. Okay, simple problem. I'll just give you the basic concept behind this particular problem. Once if the basics is clear, you can solve any application problem. Okay. So now, what is the first step? So the first step is uh, identify input and output. So this is the step number 1. Input and output variables, and decide descriptor for the same. So input and output variables are already given in the problem. So what you need to do is, it is just you have to mention the descriptors here. So what are the input? Say input 1 is dirt, input 2 is grease. Okay, and output is wash time. Okay, input 1 is dirt, input 2 is grease, output is wash time. So based on the amount of dirt and grease on clothes, you decide the wash time. This is the problem. Okay, so let me consider first, let me consider dirt X, and let me consider grease Y, and let wash time be Z. Let this be the representation. So for my X, that is for dirt, which I consider X, let me just define. So 3 descriptors: small dirt. Okay, let me call it as SD. Then let me write another descriptor, medium dirt. So this is medium dirt. Third one is large dirt. So this will be LD, right? So similarly, now I will take the second input, that is grease, which is Y. So simply I will take now, it is left to us. We can decide. Okay. So I will write no grease. So this I'll call it as NG. Then medium grease. So MG, and large grease, LG. You may ask me, can we not consider small grease? You can do it. Okay. Small grease, medium, large. Here also no dirt, but no dirt is not required. Let us write small dirt, because when we are using a machine, we assume that it has small dirt and we are going to clean it. Okay. This is how we write the descriptors. It depends on you, how you can write based on your based on the experience or based on your knowledge what you have. The third one is, we have the output wash time. So it is mentioned that in the question we can have 5 descriptors. So let me write wash time very small, then small, medium wash time, then large, and very large. So these are the descriptors we have. So very small VS, small S, medium M. Let me write large L, very large VL. Okay. In this way, what we do is, for the whatever the inputs we assume based on the question, we just write the descriptors. It may be 3, 5, 7. It depends on the question, or if it is not mentioned, you can decide however you want. You can go for more number of descriptors if possible. Okay. This is the first part of the problem. Identify input and output variables and decide descriptor for the same. Now coming to second part. So what we do it, we develop the membership function now. This is this second step. So let us go for the membership function design. Okay, membership function. Let me use triangular membership. Okay, first let me consider the first variable, input variable dirt. Okay, that is X. So I'll just write the triangular membership function. Okay, so this is with membership. This is mu of x. Okay. Let me take this is x dirt in percentage. Let me assume 0 to 100%. So this is 0, this is 50, this is 100. What I will do is, so okay, this is my medium. So for this small dirt, this one. For the large dirt, so this is large dirt, this is small dirt. This is 0, 50, 100. So we have small dirt, medium dirt, and large dirt. SD, MD, LD. This is how I have developed or I have written the membership function. Now what I have to do is I have to write the membership values. Okay. So mu small dirt x is equal to, see here, this is what I have considered. For me, small is in the range. I consider it to be small dirt if it is, the dirt is in the range 0 to 50. Please see here. If it is in the range 0, this is my assumption. This is my, how I am solving it. Okay. There may be, it may, the range can be different. That is, it depends on us. So here what I have considered is 0 to 50. I consider it to be small. So I'll just write the equation for the membership function mu SD, which is equal to, see here, 50 minus x divided by 50. Okay. So this is in the range, 0 to x less than 50. Okay. This is 50 minus x divided by 50. Okay, in the range x, if x varies 0 to 50. Okay, this is one. Second one, I will write for mu MD. Okay, so mu MD of x is equal to, so here I have two. Please see, here I have equations two I'll be writing. One is this, the other one is this. Okay, so it will be this one, x minus 0 divided by 50. Okay, the range is if x is in between 0 to 50. 0 to 50. Second one here is 100 minus x, 100 minus x divided by 100 minus 50, that is 50. 50, if it is in the range in between 50 and 100. Okay, see here, this is for small dirt. This is these two expressions for medium dirt. Once again, I'll explain how I have written the expression. Okay, listen. So here, whatever I have shown the small dirt, the variation you can see, it is this axis, the dirt in percentage, it is from 0 to 50. So how you will write the equation for the membership function? It is mu membership function of small dirt is 50 minus, this one is here, say 0. Okay, 50 minus x divided by this, whatever is there here in the x-axis, that is 50. Okay, that is in the range 0 to 50. Now coming to MD, that is medium dirt, it has two slopes you can see here. One is from 0 to 50, the other one is from 50 to 100. So here in the denominator, you will have, first one you will have say 50. That is 50 minus 0. Here the denominator is 100 minus 50. That is why I have written directly 50. So what is that first part? This one is x minus 0 divided by 50, whereas this is 100 minus x divided by 50. These are the two expressions. Okay. Now I have to write one more expression, that is mu, the membership function for the LD, right? It is, yeah, large dirt. Large dirt, I'll write here itself so that it will be more clear. So mu large dirt of x is equal to, see, that is this portion. You are considering this portion here, right? So it is simple, x minus 50 divided by 100 minus 50, that is 50. So it is equal to x minus 50 divided by 50. The range is 50 to 100. 50 x is in between 50 and 100. So this is the expression for the, this is for the large dirt. This is for the medium dirt. We have two cases here, and this is for the small dirt. Okay. Similarly, we have to write membership for function for the other input, grease, and even for the output. Now let me go to the next input, that is I'll consider grease, and I'll write the membership function for the grease. Okay, membership function for grease. So that is y. So I'll write it similar to previous. It is easy. One, if you understand, then the remaining will be very easy. So this is y. This is mu of y. So here again, it is percentage grease in percentage. So we have 0, say we have 50, we have 100. Something like this, I'll just for my reference. So here, this is medium. Okay, and I have, this is similar to previous membership function. I have written no grease, medium grease, large grease. You may ask me now, why 0 to 50 I have considered no grease. So it is just in fuzzy, I considered it as it is no grease, even though there is some, I should have considered less, little or small grease, but it is okay. Here I have already represented it. It is okay. Now let us represent the membership functions. Let me consider first membership function of no grease. Okay, so it is equal to 50 minus y divided by 50. This is in the range, y is in between 0 and 50. Second one, I'll write the membership function of mgy, which is equal to, so the first part is y minus 0 divided by 50. It is in the range 0 to 50. Second one here, it has second part. Second one is 100 minus y divided by 100 minus 50, that is equal to 50. It is in the range, here I'll write 50 to 100. Third one, sorry, and the third is mu lg. So I'll write mu lg y is equal to, so this part y minus 50 divided by 100 minus 50, that is 50. This range is same as that of previous, in between 100. So here I have the third one. So this is the second one. For medium, I have two slopes. That is why two functions I have. And this is for the first one. So I've written for first, written the membership function for the two inputs for dirt and grease. Okay. Now I have to write the membership function for wash time. Okay. Similar to this, but only difference between this and wash time is that for wash time we have 5 descriptors. That is very small, small, medium, large, and very large. Let us use a triangular membership function only, and we will try to represent. Okay. I hope you have taken down. I'll just give you some time to copy down if you have not done. Okay. I've written everything here. I'll explain now, okay, how I have got it. So what I have done here is for the output function, that is wash time, I've assumed a triangle membership function. I've just drawn a diagram, okay, a rough sketch for the triangular membership function. So here we know that very small, small, medium, large, very large. Please note that here I've restricted the wash time to only 60 minutes. You can further, you can make it more, and you can go for the other type of membership functions also. Okay. So here, after I drew the membership function, I've just write the diagram. I've written the membership function. First is for the very small. So very small is in the range between 0 to 10. Okay, if it is 0 to 10, I define it as very small here. So it is 10 minus z divided by 10. So in the range 0 to 10. Next comes a small. Small is in the range from 0 to 25 here, but here 10, here 15. Okay, that is why here you can see in the denominator 10 and 15. So how to write this? Z minus 0 by 10, that is for the first one, 25 minus Z by 15 for the second one. Then comes to the medium. So for the medium, I have written for the medium, you can see here. So 10 to this one, Z minus 10 by 15. And the other one is 40 minus Z by 15. Okay. Then comes large one. For that, you can see here Z minus 25 by 15. Other one is 60 minus Z by 20. 60 minus 40 is 20. The last one, that is okay, the last one is here, very large. It is actually in the range 40 to 60 minutes. It is Z minus 40 divided by 20. Okay, in this way I have written the membership functions, okay, for all the 5 descriptors of the output function, that is the wash time, which is in minutes. Okay. So you have written, I have colored it yellow, blue, green, purple, and okay, brown. So you can just have a look. This is how we write the membership function diagram and membership function. Okay, now this is the step 2. Let me go back. So this is the first step, identifying. Second one is membership function. Now let me go to third step, which is forming a rule base. Okay, so how to form the rule base? Form rule base. Okay, this is very simple. If I cannot complete this entire problem today, I may next class I'll take. I'll try to finish this part. Let me see how much time it takes. See, this is forming the rule base. How to form the rule base? Let me just go back and explain once again what I have done. So here for the two inputs, dirt and grease, we have assumed 3 descriptors. That is small SD, MD, LD, NG, MG, LG. Okay, you will be writing these things SD, MD, LD, NG, MG, LG over X and Y. And the inside that table, it will be filled, you will be filling it with the descriptors what you have written for the wash time. Okay, so coming to this, so I have written here STMDLD, that is one set. Second one is NGMGLG, that is the second set. See, first you can fill this diagonal. Okay, so it is actually it is clear, short, small dirt and no grease. Then the timing, washing time should be very small. Okay, simply you can fill it. Then medium dirt and medium grease, so you can simply fill it by medium time. Then last one is large dirt and large grease, you can simply fill it by very large washing time. So it's always easy to fill the diagonal. Remember, other fields of this rule base that you can only fill by your experience or by your say intuition. For example, there is small dirt is there and medium grease. Whether you go for medium time wash time or large time or very large, very small, that is you must know it. Okay, so I'll write here medium. Next, small dirt and large grease. Let me go for large. Okay, it just you are going to fill it. Then medium dirt and no grease. Let me go for small washing time. And medium dirt and large grease. Let me go for L, large washing time. Then large dirt and no grease. Let me go for say medium. You can fill L also, no problem. And say large dirt and medium green, I am filling it by L. Okay. This is how you fill the this table and you're forming the rule base. Actually, you can this actually what it gives you an idea. If small dirt, if small dirt and no grease, if small dirt and no grease, then the output is very small. Okay, this is how we develop. Now the fourth step is what we'll do is I will this is third step, say rule evaluation. Actually, this part rule evaluation is slightly time consuming. I'll just tell you how do we evaluate this. Okay. Normally, if you go for say fuzzy logic toolbox in MATLAB, once you form this rule base, then it gives you the solution. Okay, any say dirt, any percentage of dirt, any percentage of grease, you just put it. It will give you the wash time. Okay, it gives you the wash time. I will tell you how it gives. Okay, manually we can do this evaluation. Okay, MATLAB, if you using fuzzy logic toolbox, it, as I said, it will give you, say if it is very large, 100% dirt, 100% grease, you just feed, it will give you immediately, it will give you 60 what is how much yeah, 60 wash time is 60 that it will give you. Okay, so that is it is done by MATLAB, but manually how we can evaluate, I will tell you. If you understand that, then it is very easy if you are using the fuzzy logic toolbox. So now I'll take one example. It is mentioned in the question, 60% dirt and 70% grease, you need to evaluate it, right? So this I'll tell you how to do it. Okay, so now what you do is 60% dirt and 70% grease. Let me go back. So 60% dirt somewhere here, say somewhere here, correct? So here, what are the in the membership function, what all comes if it is 60%? Please see here. If it is 60%, you can see somewhere here. If I draw a line, okay. So say somewhere here, right? So MD as well as LD both comes into picture. So you have right here 60% dirt. So mu MD and mu LD both comes into picture. So what are the expressions of that? I will just write mu MD and mu LD. Mu MD is x minus, mu MD is second part, 100 minus this one. Mu MD is this one, this 100 minus x by 50. Mu LD is x minus 50 by 50. I'll write both of these equations, okay? So mu MD 100 minus x by 50. So here I'll substitute 100 minus 60 by 50, which is equal to 40 by 5, 4 by 5. Here x minus 50 by 50, it was there. So I'll write 60, substitute that by 50. This will be 1 by 5. Next is 70% grease. Let me go back to my grease membership function. Okay, 70%. 70 is somewhere, 1 second. 70 is somewhere here, right? So if 70%, it corresponds to, see here, mg and lg. Mg, so in mg, this one, second part, that is 100 minus y by 50, and lg is y minus 50 by 50. Okay, I'll write both of these expressions. So 70% grease, mu mg of y, mu lg of y, which is equal to 100 minus y by 50. So this is y minus 50 by 50, right? So here I'll substitute 100 minus 70 by 50, which is equal to 3 by 5. This is how much? 70 minus 50 by 50. So this is 2 by 5. Okay. So I have got now for the corresponding to 60% dirt and 70% grease. I have got 4 cases: 4 by 5, 1 by 5, 3 by 5, 2 by 5. See here, this is medium dirt, large dirt. This is medium grease, large grease. Now I have the 4 cases. See, one example, medium dirt, I'll write here. Medium dirt, medium dirt, medium grease. Okay, so I can make the combination. See, medium dirt and medium grease, one combination. Second one is medium dirt and large grease. Third combination is large dirt and medium grease. Fourth one is large dirt and large grease. Okay, say this is medium dirt and medium grease. Medium dirt, large grease. Large dirt, medium grease. Large dirt, large grease. So I can make 4 combinations with this, right? So what I will do is, these 4 combinations, I will just, whatever the table we had put, right, this one, I will, in this rule base, I will substitute. So medium dirt and medium grease. Medium dirt and medium grease. This is one point. Then medium dirt and large grease. This is the second point. Large dirt and medium grease. This is the third point. Large dirt and large grease. These are the 4 points. So all other things you can just strike it off. It is not interested. Okay. So now the question comes, how to fill this 4, right? See here, this is very important. Now we go for the min composition. Min composition means, so here when you compare MD and MG, see here, medium dirt and medium grease. Medium dirt is 4 by 5, medium grease is 3 by 5. So out of these 3, you will write min, okay? So you are going to fill the min value here. So that is 3 by 5. Next, this is medium dirt and large grease. Medium dirt is 4 by 5, large grease is 2 by 5. So minimum is 2 by 5. Next, large dirt and medium grease. Large dirt 1 by 5, medium grease 3 by 5. So you will write 1 by 5. Last one, 1 by 5 and 2 by 5, 1 by 5. So here you will write out of these 4, please see here, the min composition we are doing. That means we are writing the in these combinations, out of these combinations, you are writing the minimum. Okay, now what next? After this, what we have to do is min-max composition. Now next we are considering the max value of this. So out of these 4 max values, see here, which is highest 3 by 4, 5. So out of this max is 3 by 4. So this 3 by 5, if you see, it corresponds to what? It corresponds to medium dirt and medium grease. Okay. So what I have done here is for this 60% and 60% dirt and 70% grease, I have just done this rule base. I have filled. Now what I have done is last one step is remaining in this. I will just tell that. So here you have entered the minimum values. After you enter the minimum values in the table, you go for the maximum, which corresponds to 3 by 5. So here 3 by 5 is in that it is M. So you go to M of your output membership function. So here M corresponds to what? Here M corresponds to medium. See here, this is M. M is from, 10 to 25, 25 to 40. So corresponding to M, you just take down, okay, these values, Z minus 10 by 15 and 40 minus Z by 15. These two now corresponding to M, you have to copy down. Okay. So I'll just write, let me just tell you, corresponding to M, corresponding to max value of table, it is M in output membership function. So output membership function mu M of Z is, we have Z minus 10 by 15 and 40 minus Z by 15. Am I right? So these are the mu M of Z is Z minus 10 by 15 and 40 minus Z by 15. So corresponding to this, you substitute is equal to whatever the max value, that is 3 by 5, which you have taken from the table. So corresponding to this, you substitute 3 by 5. If you substitute 3 by 5 and you calculate the value of Z, I think if you do it, just how much you are getting? 5, 3. So 1 is 5 1s are 5 3s are 3 3s are 9 9. So 19. This gives you Z is equal to 19. This gives you 5 3s are 3 3 9 9 40 minus 9. So this gives you Z value is equal to 31. Now finally take the average. Take the average, that is 19 plus 13 1 by 2, which is equal to 50 by 2 25. So corresponding to the problem which is given, that is 60% dirt and 70% grease, then 25 minutes according to the our design. So the washing machine has to run for 25 minutes using this fuzzy logic inference or theory or controller. Okay, this is the complete solution of the given problem. I just took a real-time problem. I wanted you to understand how we normally do it. If it is, this is how manually, if you are designing, you are validating it. If you use toolbox, it will be very simple. Only you have to feed up to this. That's all. Any doubts?
No, ma'am.
Okay, so that's all for today. What I want is just give me 2 minutes. I will paste the link for the for today's quiz. It is at 5 o'clock. Okay, so we have some 5 minutes time. I'll take the attendance. Just give me yeah 5 to 5. Okay, 5 minutes I am giving for the quiz.